Alright, so today we're going to be talking about how to solve exponential and logarithmic equations. This is kind of the whole why we learn logs here today. Now the first couple here, these exponential equations, we can actually solve these without using logs. So the idea for these here is you want to figure out if you can write these as a common base right here. So if I can go and get something smaller, like for example 2 or 3 raised to a certain number, I can go and swap these 9s and 27s out with those. So for example, if you think about this here, 9 is the same exact thing as 3 squared. So I'm going to change this 9 right here that I have underlined. That's going to change to 3 squared, and then you still have this 2x right there. Now 27, you want to go and see if you can rewrite 27 as 3 raised to something as well. Because the whole idea is if you have the common bases, then we can go ahead and cancel your bases out. So here's kind of what I mean by that. First of all, 27, this is going to be 3 cubed instead. So we're going to change this 27 to 3 cubed. All right. So really, once you simplify this after you distribute or, I guess multiply here, this will be 3 raised to 4x and then equals 3 raised to 3. And what you do is you set your exponents here equal to each other. So we're going to say 4x equals 3, and then therefore x is equal to 3/4 right there. So the big idea with these is get a common base. So if we can rewrite these with a common base, then we're going to be good to go. Actually, I like this next one a little bit better here just because you can get a common base. It's much easier to see here. If I can rewrite this 81 right here, if I can rewrite that as 9 raised to something, then we can cancel out our bases and set our exponents equal to each other. So 81 is the same exact thing as 9 squared. So I'm going to rewrite 9 squared right there. And then you still have that x minus 1 up there in the exponent as well. So with these here, you want to set your exponents equal. And you can either distribute that 2 first, or you can write it like this. 2x equals 2, and then x minus 1. Most people are going to go ahead and distribute right away. Okay. And then you get 2x minus 2. And then if you subtract 2x from both sides, your x's actually cancel out, and you get 0 equals negative 2. All right, and usually with algebra, if we get something equals something that is, that is not equal to, we usually say this has no solution. Okay, so sometimes you'll get them where they have no solution if all your x's cancel out. Now, this next one is probably the hardest one of these here because you want to go and figure out how to write 1/9 as 3 raised to something. That's a little tricky here. So you got to think, okay, what type of exponents make negatives? If you remember back to one of your properties here, if we take a raised to negative m, that's the same exact thing as saying 1 over a to the positive m. So negative exponents make fractions. So if I go and take 3 and then raise it to some type of negative exponent, then I can probably get this 1/9. Now as far as getting 3 to look like 9, you need to raise it to 2, so we're going to do raise to negative 2 right here. So we're going to write this as 3 raised to x, and then this 1/9 is the exact same thing as 3 raised to negative 2. So we're going to replace this 1/9 with 3 raised to negative 2. Okay, and then you still have the exponent as x plus 3. Okay, now set your exponents equal to each other. Okay, after that, distribute. That'll be x equals negative 2x minus 6. And then we'll add 2x, so that gets you 3x equals negative 6. And then divide, you'll get x equals negative 2. Okay. Now, not all of them are you going to be able to go and rewrite with common bases. So, for example, something like this right here, you have 4 raised to x equals 80 right here. So we cannot rewrite you cannot rewrite 80 as 4 raised to something. So we're kind of stuck. All right, and there's kind of 2 different approaches to solving these types of equations. All right, you can do something where we do the log of both sides, or you can just think about switching your forms up here. So I'll do it both ways here. Typically, I switch forms, but you can also log both sides. And here's what I mean by log both sides. So you can go log of 4 raised to x equals log of 80. Okay, and then I guess what you want to do here is get the x here. You want to get it by itself. So we're going to put the x out in front. We're going to use one of those expand and condense properties and call this x times log of 4, and then equals log of 80. And then to get rid of this log of 4, we're going to divide both sides by log 4. And then from there, we'll go x equals just whatever the decimal of log 80 over log 4 is. And you would just use that, and you would just type that into your graphing calculator. Now, if you type that into your calculator, my notes here say that you get 3.1611, I guess. Not sure that extra one. I'm not sure if that extra one's actually there, but something like this right here, 3.16. Just about right there on that. And that is taking the log of both sides. Now, another approach that you can do here is actually, instead of thinking of taking the log of both sides, I like to think of switching to log form. And what we do typically is we say, okay, we got log, there's your 4 right there. We're going to go log base 4 of 80 equals x. Log base 4 of 80 right there equals x. And then either type that into your calculator or use your change of base property. You can go log 80 over log 4. And then you would get the same exact thing. So to me, the way on the right's a little bit easier. So I would probably do that. And then whenever you punch that out, it should come out to the same exact decimal. Okay, let's try out another one kind of like that right here. And probably from here on, instead of doing log of both sides, I'm just going to switch forms. So I always switch forms whenever you can't do anything. Like we can't do anything with this equation. We don't know how to get x by itself. So we got to go and switch forms. So always go log base 4, or I'm sorry, base 9, and then of 35, and then equals x. And then you can type that into your calculator or change a base as log 35 over log 9. And that decimal comes out to 1.6181. And that's an approximate answer, by the way. There you go. Okay, next thing here on this one, on C, you got this right here. Can't really do much with it right now, so we're going to go and do log form. We're going to go log, here's your base, log base 7 of 15, and then apparently equals 9x. Okay, and then what we need to go and do here is eventually figure out what log base 15 over log 7 is, or I'm sorry, log base 7 of 15, or log 15 over log 7. And then that's going to equal to 9x. And then whatever that is, we're going to go and divide that answer by 9. Now, if you go and do the decimal first, apparently you're going to get 1.392, and then equals 9x. And then we're just going to divide both of these decimals, or both sides, I guess, but the decimal, divide the decimal here by 9. And apparently that's going to get us 0.1546 right there. So that one we had to do one extra step after you get your decimal. Now remember, if you want to type these in here, if you recall from yesterday, you can go and do the change of base where you do log 15 over log 7. So I'll just show you here just real quick, just in case you need a recap. Log 15, and then over log 7, and hopefully that gets that decimal that we got. Yep, there it is, 1.392. Or if you hit math and then scroll down to log base. Nope, I did the wrong thing there. Let's try that again. Math. Log base, you can also type in log base 7 of 15. You'll get those same decimals there. Okay, so that's a recap real quick on how to do all that. Okay. Now, sometimes you'll get these log equations right here where you can't really do much with the log equation. So, a couple of approaches that we can do here. If it has a single log on both sides and they have the same exact base, you can actually just cancel out your bases and set the inside the parentheses stuff equal to one another. So you got something like that, subtract over your x, add your 1, and you should get x equals 4. Okay, now the big thing with your log equations is make sure you can't plug in 0 or negative numbers into logs. So the only numbers that can go inside the parentheses of logs are positive numbers. So make sure when you go and plug back in positive, you need to have a positive number inside the parentheses. I guess we'll say inside the log parentheses like that. So positive numbers inside the log parentheses. So if I go and plug 4 back in, I need to make sure that yields me a positive number. 4 times 3 is 12. 12 minus 1 is 11. So that should work out. Let's go double check this one. 4 times 2 is 8. 8 plus 3 is also 11. We can do the log of 11. So just watch out here. I bet you we're going to have an example where it doesn't work out in just a moment. So let's see what's going on here with this one. So like before, if you have logs with the same exact base, cancel them out right there. And then we'll go x squared minus 6, and then equals 2x plus 2. Hopefully if you see something with x squared and x, hopefully that's screaming out at you something like solve by factoring or quadratic formula. So with this here, I'm going to solve by factoring. I'm going to keep x squared positive. It makes our life easier if x squared is positive. So I'm going to subtract over 2x and subtract 2. So that'd be minus 2x and then minus 8 right there. And I'm going to scoot that down just a hair. So that's x squared minus 2x minus 8 equals 0. And then we can solve this by factoring. What multiplies a negative 8 and then adds the negative 2? So you can go negative 4 and positive 2. Then set your factors equal to 0. And then x equals negative 2, and then x equals positive 4. Okay, now here's the issue. One of those is negative, which means when we plug it in, it might not work out. And actually, you need to check both the negative and the positive numbers here. So I'm going to go and check and see if I plug in negative 2 right there, and actually for both spots here, if I'm going to get a negative inside of the radical here, or actually even 0. If you get 0 or negative, that's going to mess things up here. So if I go and do, I guess, let's go log base 2 of, I guess, negative 2 squared, and then minus 6 right there, that's going to give me 4, and then I guess minus 6, which gives me negative 2. All right, and you can't do the log of a negative number right here. If you go and try and type that in your calculator, it's going to say that doesn't work right there. So negative 2 does not work. So let's go ahead and double check and see if 4 works. If you go and do 4 into there, that'll be 4 squared, that'll be 16. 16 minus 10, that'll be, log base 2 of 10, which works out right there. And then we need to go and see, can we plug that into the other log right there? 2 times 4 is 8. 8 plus 2 is 10. So this we can do since they're both positive right there. So that one does work there. So only 4 works in this context. All right, so that's that. And then now we're just going to solve all of these different types of log equations here. I think down there at the bottom we got a couple of special ones there. So they're all a little bit different. Each one's got a different approach. Whenever I get exponential equations, I first look at if I can write 25 as 5 raised to something, which you absolutely can. We can rewrite 25. 25 is the same exact thing as 5 squared. So I'm going to change that 25 to 5 squared, and then you still got the x plus 1. So since your bases are the exact same, set your exponents equal to each other. So 3x plus 1, and then equals 2x plus 1. Distribute. It'll be 2x plus 2, and I got 3x plus 1. I'm going to subtract over 2x, that'll get me x. I'm going to subtract 1, I'm going to get 1. And that is your answer. Okay, number 2. Next one here, we got another one of those pesky fraction ones here. So we need to rewrite, see if we can rewrite this 1/4 as 2 raised to something. And that'll actually, so it'll be a negative exponent. And then if I just do -1, that'll make 1/2. So I need to do -2 right there. So we're going to replace this 1/4 with 2 raised to -2. Whoops, I'm writing it wrong. So 2 raised to -2, and then you still have this x minus 1, I guess, up there. Right, and then this other exponent is going to be 2 raised to 2x. So once again, if you have common bases, then you can set the exponents equal to each other. Okay, so that would be -2x minus, or actually plus 2, I guess, and then equals 2x. I guess I'm going to add 2x to both sides. That's going to give me 4x is equal to 2, or when I divide, 1/2. That's your answer there. Okay. If you can't rewrite your bases as the same thing, I cannot rewrite 3 raised, or I can't rewrite 7 as 3 raised to something, or I can't write 3 as 7 raised to something. So you can't do either of those. So this is where I switch to log form. So we'll go log base 7 of 3 equals x. And then either change the base or type it in just like that. Log 3 over log 7. Or just type it in. Both of these will get you the same decimal. Don't forget about that. That apparently will get us -5. Or I'm sorry, not negative. That'll just get us 0.5646. Make sure you pay attention to what they want you to round to. Be careful. 4 looks like you could rewrite 4 and 9, but you can't write them as the same base. So we're going to be stuck there. So anyways, in that case, switch forms. I want you to write that as 4 raised to 9 equals 3x. Log base 4 of 9 equals 3x. Okay. Go ahead and figure out what that decimal is. I don't actually have it here in my notes, so I'm going to go ahead and use the calculator for this. So that'll be log 9 over log 4. That's equal to 3x. And then I guess we're going to find that decimal and then divide that decimal by 3. So log 9, close parentheses. Make sure you close your parentheses up. And then divide it by log 4. Apparently that decimal is going to give me about 1.5. I guess let's go to the nearest thousandth. 585. Alright, and then that's equal to 3x. So I just wrote that down right there. And then now we'll go and divide that decimal by 3. And apparently that gives me 0.528. Okay. And there you go. So sometimes you'll have to do that extra division step. Okay. Next one here. Oh yeah, dealing with E. Yeah, these are kind of special here. Alright, so with this one, before you switch it to log form, you can't really do much with it, but before you switch it to log form, I want you to add the 2 to the other side first. So we're going to write this as E raised to the fraction x over 2, I guess equals 7. And then we're going to switch to log form. We're going to write log base E of 7 equals x over 2. Now log base E, right there, if you write log base E, that's the same exact thing as natural log. So I'm going to go natural log. You can write the little e. Some people write it, some people don't. But natural log of E, base E, of 7, and then equals x over 2. Now you don't actually write the e there, you just hit the natural log button. So we're just going to hit natural log of 7, that'll give us that decimal. So apparently that decimal is 1.946, I guess, once you round up. And that's equal to x over 2. So I would write that right there. And then to get rid of a divide by 2, we're going to multiply both sides by 2. So just take that decimal, whatever it is, hit times 2. Apparently that gives us 3.892 once we do that. And then that'll be our answer. Okay, that's a few of those. Just 4 more problems here. Almost done. If you got log base 7 of something equals log base 7 of something, you can essentially cancel the logs out and set what the numbers of the logs equal to each other. So I guess I'll add 3x to both sides. That'll give me 4x. And then subtract 2. That'll give me 0. And then divide both sides by 4. That'll get us 0. And then what I want you guys to double check, since we got 0, well, really you should always double check. Let's make sure that doesn't mess things up if I plug it back in. 0 plus 2 is 2. That's a log of a positive number. That should work. Let's double check this one. 2 minus 3 times 0, which is 2 minus 0, which is 2. So that works out as well. So this is actually a solution that works. Okay, let's look at what's going on here with this one. So you got 2 logs on both sides. So those can cancel out. 3x minus 5 apparently equals 1/3 x plus 11. Alright, some people don't like fractions. So if you want to get rid of all your fractions right away, nice little algebraic step you can do is multiply everything by the common denominator, which in this case there's only one denominator. So if we do all that right there, that'll be 9x minus 15. 1/3 of 3x is just x, and then plus 33. And then now we're done with the fractions. So I'm going to subtract over x. I'm going to get 8x. I'm going to add 15. I guess that gives me 48. And then I guess to go back and divide, you'll get x equals 6. And then just quickly double check. Can I plug in 6? 6 times 3 is 18. 18 minus 5 is 13, so that works out. And then let's go see, can we plug that back in up to this log here? 1/3 of 6 is 2. 2 plus 11 is 13 as well. So we are good to go right there. Okay. Number 8, got natural logs on both sides. Cancel out your natural logs. Those are good to go. 4 minus 5x equals x plus 10. And then subtract over, or actually I'm going to add 5x to both sides. That'll give me 6x. And then I guess I'll subtract over 10, and that'll give me negative 6. And then I guess divide, and that's x equals negative 1. Now watch out, that might not work if we plug it back in. Let's double check. Negative 1 times negative 5 will be positive 5. 4 plus 5 should be 9, so that works out. And then also, oh yeah, look here. Negative 1 plus 10 is also positive 9. So both of those work out, so we're good to go. Alright, now last one here. This one's kind of a special one, so we're going to put a star next to this one here. Notice that you have 2 logs, but they're both together on the same side. So we're going to use one of our properties that we learned from yesterday. We actually have to condense this down to a single log. Can't really do much with 2 logs. And since they're not on both sides of the equal sign, and it's not just logs right there, even if I move this entire log piece to the other side, we still got other stuff. It's only when it's a single log equals another single log is when you can cancel out. So our approach for these is condense it down into one log. So we're going to write log base 6. And if you have something plus something, or a log plus a log, you go and multiply both of the things together. Kind of like this right here. Alright, and x times all this here, we're going to distribute that. So we're going to write this as log, and this is x squared plus, I guess, 5x right there. And then all of that equals 2. Once again, we still don't have logs on both sides and just logs. So our approach for this one actually is we're going to switch it back to exponential form. So I'm going to take this 6. We got 6 raised to 2 equals all of that stuff. 6 raised to 2 apparently equals x squared plus 5x. Okay, and then once you get from there, we can say 6 squared, that's 36. And then we can actually subtract over 36 and then solve by factoring. So this one's got a lot of extra steps here that we got to do. Okay, to solve by factor and figure out what multiplies a negative 36 and then adds, I guess, to 5 right there. So we can use 9 and 4, or 9, I'm sorry, 9 and negative 4. And then set your factors equal to 0 and solve. So you'll get x equals negative 9 and then x equals positive 4. Now, typically when you get two answers, sometimes one of them doesn't work out. So we're going to just go quickly double check when we plug back into the very, very original log equation. So if I go back and plug in negative 9, I can see right there I'm plugging in a negative in for a log. 9 will not work. Now I just need to go double check and make sure 4 gets me positive logs. So you'd have log base 6 of 4 plus 5, that'd be 9 right there. We can do log of 9. And then if I plugged in 4 to the other one, we can do log of 4 right there. And they're not equal to each other. They don't need to be equal to each other. They just need to be positive. So watch out for those. I know those are pretty common on tests right there where you got to get it down to one single log and then switch forms. So anyways, that is it for today.